Bismillahirrahmanirrahim. In this video, we'll be discussing example 8.4 from Mr. Chapman's book, 5th edition. And this is on the request of a student. So let's see the question. The motor in example 8.3 is now connected separately excited. So in 8.3, it was not separately excited, but here they have shown the same motor is connected as separately excited. The motor is initially running with a VA of 250 volts. So this is VA and it is running at 250 volt. IA is 120 ampere. So this current, the armature current, is 120 ampere. And N, that is the speed of the motor, is 1103 revolutions per minute, while supplying a constant torque load. So the torque is constant, or the load is constant, we can say. What will the speed of the motor be if VA is reduced to 200 volts? So this is reduced from 250 to 200 volts. Now let me show you a funny example. You see in these two videos, the two pictures, same load or same torque, we can say. The persons are different. One is young man and the other is old man. So we're saying that this is equivalent to VA 250, the driving force from here 250. And the old man, we can say that it is equivalent to 200 volt. What will be the result? Can you guess? Okay, since the load is constant, torque is constant, only VA is changing. Therefore, in this case, the speed will be less. So that is what we'll see in this example. So the question is, what will be the speed of the motor if VA is reduced to 200 volt? And these are the parameters given. And this resistance is also given, armature resistance. So the first formula that we'll be using is the formula for induced voltage in the machine. The EA, this voltage here, and this is actually, in case of a motor, we are supplying voltage to drive the motor. And what is EA then? I'm sure you must have heard it, that this is called induced voltage, or in the old time they used to call it back EMF. The motor generates a kind of a EMF which opposes the input voltage. So this EMF is dependent on a constant K, which depends on the motor design. The flux phi, flux is produced by the field and then multiplied by the speed of the motor. Now the ratio of the internal generated voltage at one speed to the internal generated voltage at another speed. You see, you can just use, you can call this NM2 and NM1. So this will be, then EA will be EA2 with NM2, and this will be called EA1 with NM1 and phi2, phi1. Now, since the flux is constant because the field is not changing, therefore phi is constant, and therefore this will cancel and the K cancel because the same motor. So we'll have EA over EA2 over EA1 is equal to NM2 divided by NM1, two speeds. And from here we can get the formula for the new speed as EA2 divided by EA1 multiplied by NM1. So what we need, NM1 is already given here. We need to calculate EA2 and EA1. Let's see. Now look at this circuit. We need to calculate this for two different voltages. The general formula, we can say that EA is VA or VT, terminal voltage, divided by the voltage drop here. Since this is voltage, this will be higher. So this minus the drop will give the generated voltage or the induced voltage. For two cases now, okay, this is also called VT, terminal voltage, or VA. So we will follow this, that it is VA minus IARA. Now supplying a constant torque load, as we have seen the bicycle case, torque induced is given by this formula. And in our case, the current constant torque means all the three parameters, that is K, phi, and IA, will be constant. That means the current IA will also not change. Okay, now the first case, EA1 from here is VA1 minus IAR1. Now remember, since IA is constant, we are not writing it as IA1. It will be IA in both cases. Now plugging in the values in 250, then 120 from here, and this resistance is 0.03. So we get the generated voltage EA1 246.4 volt. Then coming on to the new voltage, when their input is 200 volt, same formula, we just changing it EA2, VA2, this remains same IARA. So 200 volt minus 120 into 0.3, it will give 196.4 volt. So the generated voltage has reduced. And now we come onto the formula for the speed. This was the formula. EA2 is 196.4 and EA1 is 246.4 and NM is 11.1103 revolutions per minute. So the new speed will be 879 revolutions per minute. So remember, the old man, with 200 volt, the speed will be reduced. I hope you have been able to follow this. Please let me know through comments. Thank you.